Hello, everybody. So here's our first lecture. Again, welcome. I know this is probably new for most of us. It is definitely new for me. So I'm, like I said, learning as I go. So this first section, this is just 1.1 in the book. This will be pretty quick, is mostly just vocabulary. And a word about vocabulary in general, I won't ever give you a vocabulary test where you have to, recite the definitions of these words. So don't focus on memorizing the particular way I write down the definitions. You'll note that different books have slightly different definitions the way they write it. What is important is you understand what they mean. I will be using these terms when I lecture, in quizzes and exams, as we move forward. And so these words need to become part of the way that you communicate, so that when I say something like parameter, which you might not know what we mean by that yet, you don't have to stop and think about it, right? That after a week or so, words like that will become very commonplace for you. That also reminds me of another thing. The word parameter might mean something in the regular world, but in statistics we might mean something very specific by it. And we'll see a lot of words like this as we move forward that have some kind of common meaning, but in statistics there's a very specific meaning, and we need to make sure that we're using the specific meaning when we're in this course, right? This is kind of common for sciences in general, right? There's always very specific meanings to words that might be used in other ways in other places in the world. So let's get started with some of our vocabulary. There really won't be numbers or barely any numbers in this lecture. So let's begin. So the first vocabulary word I'll get to is just statistics. So one way we can think about statistics is the collection, analysis, interpretation, and presentation of data. Okay. So it's fine to have data, right? But we have to understand what the data means, and that's a big part of what statistics is about. And it's also going to be about how do we communicate what it means to other people, right? Things like presentation become very important. So let me give you an example of this kind of a thing. Let me switch to a different document. There it is. Okay. So I'm not going to go through the details of what this document is, but I just want to show that it has a variety of what we just talked about: collection, analysis, interpretation, and presentation of data. So first of all, this that we're looking at is something called a spreadsheet. I suspect many of you are familiar with spreadsheets to some capacity. It's fine if you're not. We will be using them as a major technological component of this course. So for now, I don't want to worry too much about this. We'll get into some tutorials on how to use them. But I do want to just point out, for instance, what I've got here is 2 columns of data. These are heads and tails, okay? So what I've asked classes to do in the past, when we've met in person, is to take a coin and flip it 12 times. And I recorded from everybody the heads, or they recorded for me the heads and tails they got from those 12 tosses. So I'll make it a bit bigger. I'm not sure how legible these things are on the video. We'll work through those technical issues as we go. So here are our columns of data for heads and tails. This is collection of data, right? There are various kinds of analysis that I've done here. So for instance, right here, this number, 0.5833, this is the the average number of heads this person got per toss, right? A little more than half per toss on average. And again, if this stuff doesn't mean anything to you yet, that's fine. I'm just pointing out that this tells us something out about the data. Or another way I could say this is they got about 58% heads out of their 12 flips. So we're beginning to analyze the data. This is another analysis that we'll do down the road. You'll see over here various graphs. This is something called a histogram that we're gonna look at many histograms in this course, and you'll even build some histograms yourself. These are some good presentation of data, right? This is, instead of showing somebody columns of numbers, they can look at pretty pictures that actually tell us something. Or for instance, here's a simple graph that just has heads and tails. Heads is the blue, tails is the red. My title seems to have disappeared for some reason. But in any event, right, it's much easier to tell at this glance at this graph that over the course of many students doing this experiment, we got about the same amount of heads and tails, right? It's much easier to tell that from that picture than it would be from scrolling down these two columns of numbers, right? That you'd actually have to add them up to know this, whereas in a picture, it's very simple to show how close those two are to each other. Right. Here's another presentation. It's another table of data, but I've compacted all of that data into something much smaller. In this case, I'm showing this column for data values is how many heads did each person get, right? So for instance, the frequency, these are all things we'll learn later, but I'm just showing you an example of presentation. One person got only one head. 11 people got 5 heads. 9 people got 7 heads, and so on, right? So this is another way to present data, and it helps us analyze it. This is something called a frequency table. This is another thing that we'll look at multiple times over the course of this course. So in any event, I'm just giving you an idea of what kinds of things we might see when we're doing statistics, this collecting of data, and then analyzing it, interpreting it. We'll start to decide what things mean. For instance, I might interpret this graph here to mean, oh, coins come up about half the time heads and half the time tails, right? That's an interpretation from that graph. Okay, let's go back to our vocabulary. Give me 1 second. There we go. All right. So what is our next word? So we sometimes divide up. Oh wait, sorry, I've got to share that screen with you again. Give me 1 sec. Okay, so we will often divide statistics into two big categories. We will have descriptive statistics. This is when we organize and summarize data. Okay, so with descriptive statistics, we're not trying to make any interpretation. We're just saying, here's what is, right? So showing you how many people got heads and how many people got tails is just collecting and summarizing the data. Instead of you looking at that whole table, I can just tell you 1,137 of those coin tosses were heads, and 1,100 and I think it was 18 or something like that were tails. That's just summarizing the data instead of reading off a list of heads, 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 tails, heads, tails, 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 heads, and so on, right? We summarize the data and organize it to make it easier for somebody to understand. All right, let's look at the other kind of statistics. Will be inferential. This is, let's say it this way, formal methods to draw conclusions. Okay, so why do we do stats? In order to help us make decisions, right? And what kind of decisions would we make? Well, for instance, with that heads and tails, I might look at those statistics and say, I'm pretty sure there's nothing tricky about this coin. It's a typical coin, and it seems to land heads about the same amount of time as it lands tails. If I did that experiment with another coin and got 1,300 heads and let's say only 900 tails, I might come to the conclusion that this is a trick coin, right? That's a lot of tosses to have happen and not have an almost completely 50-50 split in heads and tails. Then I would start to suspect that there was something else going on. That would be an inferential statistic, right? Right now in the world, there's a lot of there's a lot of statistics in general going on, right? One of the big decisions people are making constantly is how to deal with the spread of this virus, right? What measures are good enough to slow the spread without causing other problems where the solution becomes worse than the disease itself, right? Taking it to an extreme, for instance, if we insisted that no other people ever come in contact with anybody else, we would certainly stop the spread of the disease, but we would also stop the sale of food, which people need. And so, you know, a less extreme example, somewhere in the middle, it becomes less clear what's the obvious choice. And so people are using statistics to make educated guesses about what are the likely outcomes under certain decisions. Okay, another word let's look at is probability. We won't do much probability in the beginning of this course, but as the quarter goes on, probability is going to become a big part of what we do. So we'll study stats for a couple of chapters, and then we're going to take a turn and study probability for a while, and then the end of the quarter is the two of them coming together and becoming linked, and that's when we can do some really interesting things with these things. So we have kind of a lot of build up to do. So for now, we'll just call probability a tool to study randomness. Right? We'll try to determine how likely an event is to happen, or what is our confidence in an event happening. There's different interpretations of probability, which we won't get too deep into. We'll generally think of it as what is the chance. We'll use it to determine the chance or likelihood of some event happening, and we'll try to give confidence in those assertions. So those are the big things. When we're studying statistics, we're going to be looking at, we're often going to be studying some kind of problem, right? There's something we're interested in that we want to go study. So I'm going to break apart the basic pieces of the studies that we will be looking at for our next set of vocabulary. And then we'll do an example to finish this video off. So our first word is population, right? This is one of those words that has a common meaning, but we're going to mean something very specific. What we mean by this is a collection of persons, things, or objects under study. Right, so it is the group of things you're interested in studying. So for instance, right now we are interested in studying the population of Earth and its reaction to this particular virus, right? But you might do a statistical study on like how long it takes bananas to start to turn brown. And so then your population would be bananas, right? Or I might do a study on, I might be curious about the size of buildings in Seattle. And so my population would be the buildings in Seattle. So a population doesn't have to be a human population, it can be any kind of population that we are interested in studying, including objects, or even things like, I could be interested in studying, you know, weather on days of the year. So the days of the year are my population in that case. Most of the time, however, when we study a population, we don't study a population. It's very difficult, for instance, to get data on every single person on the planet, if that's who you're interested in knowing things about. So what we do is we find a sample. A sample is a portion or subset of the larger population that we study. Okay. Right? It is very, very, very difficult to study entire populations often. For instance, right now we know that we're getting ramped up for another presidential election, and so we're seeing lots of statistics about voters, right? So the population there is all likely voters, everyone who's going to vote in the 2020 election. When you see polls about who voters are favoring, they're not asking every voter, they're asking a sample, right? And sometimes surprisingly small samples, right? You're talking about millions of voters, and sometimes they'll sample a few thousand to get those numbers, right? Because it's very difficult to ask every voter. Voting is one of the rare cases where we do eventually ask the entire population. We do that when we actually go vote, right? On that day, then they do get a complete study of the population. Sometimes we call this a census. We're used to the census just being when we fill out those census forms every few years. But in any study, if you actually study the entire population, you can call that a census. So on voting day, we actually get a census because we study everybody and we find out precisely what their voting preferences are. We can get in arguments about how accurate our counting is. That's not for this course. But usually a sample is the best we can do, right? So when you read statistics about the average height of an American, they don't have height data on every American. They have height data on some Americans. They use that sample to estimate the average height for the population. So what else? Well, I've already been using this word, but let's write it. Data. Data are the results of sampling a population, right? So I want to know the average height of people. I go out and ask 500 of them, and I get a list of heights. That's the data, right? So the sample was the people I asked. Sampling is when I go ask them, and then the data is the results of that. Or in the heads and tails coin tosses I just showed you, that data was the results of sampling, where I was sampling coin tosses, and the data was the result, heads or tails in each case. Okay. All right, so now we need a couple other words. Let's say the parameter. The parameter is a number representing a property of the population. Okay. And I'll give more detail on that in a second, but I want to compare it right now to a statistic, which is a number representing a property of the sample. Okay, so they mean almost the same thing, but when I say parameter, I'm talking about the population. When I say statistic, I'm talking about the sample, which is nice. They start with the same letters: population, parameter, sample, statistic. So, for example, back to the election, if we say 52% of likely voters favor Trump, that is a statistic. Right now it is, right? Because if somebody has that data right now, that means they've sampled the population. On election day in 2020, when the result comes in, we might say such and such percentage voted for Trump, such and such percent voted for Biden, and those would be parameters because they are the actual numbers for the entire population. Right? Most of the time, we are dealing with statistics because it is rare to get data from everybody, right? Sometimes within organizations, for instance, South Seattle College, we can often get, we're a small enough community that we can often get full data on everybody. Although even that's surprisingly hard, even at an institution of our size, to get, for instance, if I wanted commuting data on every student in the school, what's the average commute length? I could probably get most of the students from somewhere, asking teachers to survey their students, but invariably we would miss a few here and there. And so it's very difficult to get the entire population. So usually we have a statistic, and we hope that the statistic is a good estimate of the parameter. That's the goal, is that the statistic will estimate the parameter, and the better we do at collecting data and running our analysis and so forth, then the better the estimate is, we hope. But we'll get into those details down the road. All right, one more piece of data, one more piece of vocabulary, variable. This is the characteristic of interest. That we determine for each member of the population. Okay, so the variable is like a concept. If I'm studying, heights of Americans, and so I go out and sample 500 Americans, the variable is the concept height of Americans. Then the data is all their individual heights, right? The data are the actual numbers, and the variable is the idea of the height of the people. Or in the election example, it is the variable is who's your preferred candidate, right? Or the preferred candidate of voters is probably a better way to say that. And then the data is the list of who each person said they preferred, and so on. Okay, so I think I will stop there on this video. This ended up being longer than I thought. I want to do one more example and a few other ideas, but I'll put that in a separate video so these don't become so overwhelming. Great, thanks.